This lesson is again going to be on RESTful web services. Last time we saw kind of the intro and the key concepts. Today I will recap a little bit the concepts, and then we look into a very simple example, Starbucks. So a web service for Starbucks. I hope you all know what Starbucks is, but it's not necessary to know that precisely. Okay, so back to RESTful web services and the CRUD operations. So we want to talk about creating, reading, updating, and deleting resources on some remote web server. So let me put this here. As we said, we have the four key or the principal operations of the HTTP protocol. We have POST to create and maybe update, to create, let's say. We have GET to read, we have PUT to update, and we have DELETE to, of course, remove resources. Let's recap the logic of this. So POST creates new resources, and the server decides on the URI. So you have one endpoint of the web service, which is the URI. You send something to that. The server creates a new resource and sends you back the URI of this newly created resource. So in the future, then, you can use this newly created URI to directly talk to your resource. Let's see, programmatic, this is what we saw last time. Today, I want to show you really some code examples. Code in this case is not programming code, but it's HTTP headers and some XML, for example. So this is how a POST request is sent in HTTP1 over the internet. So you have the POST instruction on top, content type, you declare that you are sending text/XML, meaning XML data, then the host, so this is here, you see the author did some test on his local host, so this is his own machine. Then content length, okay, it's not there, and keep alive, these are some additional instructions, and this is the body of the message. So in essence, you say post XML this, and the URL in this case, it's just the slash, it's the root URL on his local host, and this is the body. And this is a POST request. There's not much more. You send this to a web server, and you get a response back. What you get back is a 201 created response, for example. So this is something we did not talk about last time. The HTTP protocol has these verbs, operations, methods, these are all synonyms. And it has lots of response codes, 100 something, 200 something, 400, 500, and so on. Look up in the internet HTTP, and you will see there are dozens of different response codes. But there are some that are important, like 201 created. It's a success message. It's a simple code that tells you things went right. And in this case, it's really trivial, the response you get. It's a 201 created. So everything okay, I did it. And this is now the URL that you can use to refer to your newly created resource in the future. This is a URL you did not know before. So that's the important thing. When you do the post, you don't know yet at which URL this piece of XML is going to be stored on your server, meaning not your server, but the remote server. That's why you do a post, and you ask the server to create something and to give you the URL back. And this is the response. So this is really a minimalistic example, but that's all you need. Create it and the URL of the resource. Now you can refer, or you can use this URL to work on the resource in the future. If you want to update it with a PUT, we will see the example, and so on. So about the error codes, there are these 400 and 500 codes. The 400 ones are error codes by the web server, and the 500 ones, if I'm not completely wrong, are the error codes that have to do with your client. Maybe you have a client that is not able to understand the right media type, so if the server gives you XML and your client is not able to read XML because it tells this already in the request, then there might be a 500 HTTP code.
It's actually the other way around.
Or the other way around, yeah.
Yeah, it's like
Yeah.
501, I guess, internal system error. So then you have the 404 when you don't get the resource, 400.
Yes, so the,
Unauthorized.
okay. So I said about the 500, I'm not sure. The 400 ones is, for example, the typical 404 error is the one you get when you invoke, when you want to load a website and the web server is not able to find the website, the page. Then it's a 404 message, meaning the server is not able to find the resource on his hard drive or whatever. About the 500, I'm not sure. I thought it had to do something with the client, but I would have to look it up myself. So if you do regular web browsing, usually you don't see much about the 500. You only have the 404. So what do you do if you get an error? So you try to do a post, but you get an error. Well, you cannot talk to some guy and ask him what happened. You have to talk to the machine. So the machine where you would like to create your new resource. So what do? You start investigating. We have the other HTTP methods. So do a get, as explained here. Do a get and find out something about your resource. Maybe the resource is already there or whatever. Do get, try to explore the remote service and try to understand what is there. And we will see there are then also other HTTP header options that can be used to understand what is actually happening on the remote server. And as said, when you do a get, maybe you understand that you did not use the right data format or many different things. In the end, just do a post again, and you create it once you understand how to do this. About the post, this is the tricky thing with post is this, that we saw this last time. There are the two properties, safety and idempotency. So post is neither safe nor idempotent. Safe means it doesn't change the state on the server, so meaning it does not change the state of resources. And idempotent means that you can do the operation as many times as you want. It changes the state, but only once. So here we have another example. X is 4 is an assignment that each time you execute it will assign 4 to X. But if you do the incremental assignment, X plus equals 2, then each time you add something new, and of course each time you invoke it, X will grow. And the same happens with, may happen with post, for example. So if you create post on one URL, you send a post message to one URL, the server will create, in our case here, will take the piece of XML, create a new resource for it, and send you back a URL. If you do the same post again, the server will probably not understand that this is exactly the piece of XML you sent before. Or maybe the server understands it's the same piece of XML. But how can the server know whether you actually want to create two resources of the same, with the same content? So it's up to you to manage this. The server only knows it gets a piece of XML, creates a new resource. In this case, you would create multiple different different new resources. About get. So we saw get is getting the resource back. Now that we created something on the server, let's see how we can actually get the information and check whether what we created is really on the server. Let's go back here to the result. Actually, it's not. I'm a bit disappointed I didn't check this, meaning I expected the examples to be connected. I expected here to get, we do the post, we create something, we get the URL back, and then with the get here I expected now to see the same URL we got in the post. But let's imagine that it's the same URL. What we do a get on employees with a specific ID, so this is the resource, and this is only the request, and we say we want to get XML back. The server here in this case is crmexample.com, so we changed completely the server. But it's not important. As said, with the get, this is what the web server usually does. most of the times, if an error, then you get the 404 error, which means that the resource is no longer there. And as said, it's safe, it's idempotent. You have a problem, just go on doing it. Just go on. And of course, when after 10 times that you see that there's always the same error, then probably the resource is really not there. And you need to check somewhere in the documentation of the service or of your website whether this is still the correct URL or not. But the idea is this: if you get the 404 or whatever other error message because of network errors, just redo. If you get the 404 several times, then it's probably not just a network error or a communication error. It's probably really that the resource is not there. Now, put semantics. So put creates, this is now, maybe I can show you something. So put creates also new resources like post. But as we said last time, the difference between post and put is that with put, you already need to know the URL where you want to place your content. I thought about this morning. For example, if you already did an own website, then typically you have a hosted web server somewhere. For example, my website runs on Aruba somewhere in Italy. And then this is where you access your website. And then you also get an additional account, the FTP account, and you use your FTP account to connect to the server, and you use the FTP account to upload new files. So this is actually tricking, or let's say, not tricking, it's actually not fully HTTP compliant. You could do without FTP. So that's it. If the web server supported the put operation, you could directly put your new local files onto your own website. And for example, if you have already an index HTML on your website and you want to add, I don't know, friends HTML, then you know that what you want to create is a resource on your website of which you know the URL, the first part, and you know that you would like to call this new file friends.html. So actually, if the web server supported the put operation on your website, which is not the case in most web servers today, then you could just issue a put request to the web server without going through FTP. It's just that most of the web servers are configured in such a way that you cannot do posts freely, because they are afraid, of course, that post means you can create whatever you want on the web server, and maybe they are also not confident that there won't be any abuse or security leaks or so on. Fact is this: the web server would allow you to upload files with the name that you give them, but this option is typically not switched on. I tried this, for example, with my own website. I think I don't have to go out. I can only change. Here we have this tool I used already last time, the Postman, which I just closed. Which I want to recall is, it's just a graphical UI that allows you to issue HTTP requests easily, interactively inside the web browser. But this request you would then program in your code. So if we go to my website, this one, we get something here, and I anticipate something. We go to the options, and I ask options to my website, and I get this back. So this here is the key information we get back. My website allows me to do get operations, head operations, post operations, and get and post are the most two important ones in websites. Get is just read, and post is when you want to send back data from a form. And then there are the head options and the trace. No idea what the trace does, but it's not important. Head and options we will see later. And so in this case, my web server does not allow me to put web files or files directly into my website through the web server. That's why I have to bypass the web server and to essentially use FTP that gives me access then through a completely different channel, gives me access to my folder on the web server. Okay. What happened here? I don't know. So this presentation goes on automatically, and I cannot stop it. So no. Get goes wrong. Put semantics. Okay. So what most of the times is allowed instead by the web servers is this second part of the put operation, which is it allows you to update existing resources. And this is maybe something that you need to properly set up your web server, and you need to implement this yourself with your own web service that runs on that web server. But this is the more important part, where you, after the post, you get back the URL of the resource you created on the web server, and now you can use this to update it. To update the resource, you just send something new. Here we have an example. There is, but the example afterwards is better. But anyway, we have here a put with a new body, a new piece of XML, and this is going to overwrite the XML of the resource that is already located at the URL on top. So whatever is there is going to be overwritten by this put message. And the response of a put is, in this case, a 200 OK, the location, and most of the times, but not mandatorily, the response gives you again the representation of the resource you created. So essentially, the same XML that you sent and uploaded. So when put goes wrong, again, we have the error messages, and in this case, really, so put is idempotent. You can just do it as many times as you want, hopefully, until you get a 200 OK message back. About the incompatible states, I will come back to this later. It's a bit an anticipation now. The delete semantics is very trivial. Again, with the website, actually, you could delete old HTML files from your website easily by issuing simple HTTP requests to your server, but this is disabled usually. That's why you, again, use your FTP account and go and you delete files via FTP. One key thing here in REST is the deletes are logical, not physical. So what does this mean? If I say I want to delete the HTML file from my web server, and I do this via FTP, then I really connect to the removed folder, and I delete the file. So this is a physical delete. I physically drop that file from the removed server. But the REST protocol does not require you to do this mandatorily. Imagine that we said last time that resources must not be only files stored on the web server, on the hard drive of the web server. They could also be entries in a database. So we spoke about Amazon or about similar websites. You have books, you have orders, and so on. And they are typically not, each individual book is not a file on the web server. They are just entries in a huge database. And whether you really delete the entry from the database or not is not important. You can just flag, for example, one entry in the database as deleted. It's physically still there, and that's good. So it's good to keep track of what was there in the past and so on. With your website, if it's just an HTML file, who cares? Just delete it, and maybe you have it anyway in your local machine still. But if you update remote databases, most of the time you don't really drop the things that you have stored. You just flag them as not available anymore. And then if somebody else uses the RESTful, let's say your RESTful web service, the service will check before giving an answer, the service will check whether this URL corresponds not only to a resource, but also to a resource that is actually flagged as available. And based on this flag, it will then give you the answer 404, meaning no longer there, or it will give you a 200 OK message. So that's the difference between the logical and the physical. So if you really delete a file, that's a physical delete, it's away. But this is not mandatorily implied by HTTP. You can just mediate. The service can mediate between the real physical storage and the delete operation and what it tells you. Then with delete, again, if everything works well, you get a 200 OK, and maybe in the body, this is always optional. So in the body, maybe you get a piece of XML, which is the content of the resource you've deleted. And again, if delete goes wrong, just delete, go on deleting. It's not an issue. It's not an issue because you always refer to one specific URL. And this one specific URL is maybe the key to understand the idempotency problem. If you do a get, you say get on this URL, and this URL refers to the specific resource. If you do put, then you do put on a URL, and the URL is the URL of the resource. If you do delete, the URL is the URL of the resource. If you do post, this is not true. If you do post, you post on one URL, and the resource is not yet there. The server creates it for you, and it sends you back another URL. So there are these 4 operations. 3 of them really talk to a specific URL which identifies a specific resource. Post has a specific URL, of course, we are in HTTP and in the internet. But that URL is actually not the URL of the resource you're talking about. It's kind of a gateway or a manager or whatever. It's not the resource you're talking about. The URL of the resource you're talking about, you only know once you get the feedback from the service that tells you the location of the created resource. This is maybe one way of understanding the idempotency. Yeah. So whether you get error messages, then maybe deleting is not possible, and there may be different reasons. Again, you explore then with GET and with different HTTP headers what went wrong. Okay, so in summary, what we saw are these CRUD operations: create, read, update, and delete. So the question is, are they good? Well, yes, when we saw it's basically database management. You just treat a remote web server as your database. You can create, read, and so on. Maybe that's not enough. So it's only part of what the HTTP protocol actually gives you. So there are more advanced features that allow you to implement more advanced capabilities. If you use only CRUD as we saw it right now, it's a bit stupid. I mean, it lives in a bit a good world, but it has, for example, 3 shortcomings. It ignores hypermedia. Okay, what is hypermedia? Whatever media with hyperlinks. So with CRUD, you don't manage the interlinking of resources. This we said last time is one of the key features when you do a web service or whatever data model. So you don't just place entities or resources, you show how they interlink, and that's the important thing, because by navigating through the links, you actually interact with the remote service. But just CRUD doesn't do anything. You need to have a media type like XHTML or HTML or Atom also, where there exists the explicit keyword link that tells you that a piece, plain XML doesn't tell you anything. When it can be everything. You define your own dialect, it's called in XML, but nobody understands whether a given element is a link. But there are standardized languages like XHTML where you have the link construct, and this can be automatically identified and can be automatically interpreted as a link, and it can be automatically navigated. So this is hypermedia. Then CRUD encourages tight coupling through URI templates. This is something I told you last time. There are the two schools of how to access different media types of a RESTful service. Either you give each media type a new URL, meaning there's you have /friends, and then you can have /friends /text or /photo or something, and you encode the media type there. And then what you could do is a URI template here could be, for example, that you have it would be probably /friends / then you have the identifier friends 527 and then /text or photo. And the identifier is the variable part of the URL. So it's when you program, we always automate things. It's quite trivial to say, it's just the identifier that changes. I always want to have the photo of my friends, and the only thing that changes is the identifier. So you keep in your source code the URL, but you drop a specific identifier and you put a variable there. So you make the URL a template, and depending on who you want to get the picture from, you place the right identifier there. But the problem is this is then a tight coupling, because in your code, in your client code, you store the structure of the URL, and you think it's enough to just replace the IDs based on which friend you want to talk to. But that's not enough. As I told you, the service might change, URLs might change, and then your whole code breaks. That's why this is not good. And finally, CRUD encourages server and client to collude. This is a bit tricky, but we will see an example later on. The concept is very trivial. You do a post, you create a resource. It's there. Maybe you create an order, we will see. Then what happens? The resource is there, and we saw there are two different types of state. One is the application state, which is the state, your state of how you interact with the service. And then there's the state of the resource you created. I mean, just to say, imagine there's the system admin of the server and he just deletes files randomly, then you created it, but somebody else might just have deleted it. But if you place an order, so meaning that is a state change. I mean, you think it's there, but the physical resource is no longer there. Another thing is that you put an order and somebody processed the order, for example. So if the order has been already processed, you might no longer be able to change things of the order. If you order 5 books and then you say, oh damn, I actually wanted to have another one. Let me try to add a 6th book so that I get all books with the same shipment. If the order has not yet been worked on, it might still be possible. But it has been worked on, then you have to do a new order, essentially. And that's what can happen here. So server and client colludes. This means the resources are there on the server. You get the representation of it, and you think the resource is in one state, like created. And then you want to update it. But in the meantime, somebody on the server did something. For example, delete the resource. But you are not aware of this, because you only remember what you did last time, and you have your representation on your machine. And then you just do a put request in order to update this resource on the remote server, and what you get is an error back. And you say, how? When I just created it, I do a put on exactly the same URL, and I get an error. Cannot be. Can be. This is the problem here, that there's collusion between what happens on your side and what happens on the server side. So in order to understand these things and what is really going on the server, there are some more advanced, I don't know how are they called, features of patterns, or it's HTTP, they are the header instructions. So you can talk a little bit to your web server before you actually do the actions. So the key actions are always create, read, update, and delete. But as I just explained, it's maybe good to talk first to the server and to understand whether the resource is still there or whether the order is still open before saying delete and create and so on. So there's one thing of one operation is the head. So head is like get. You know the URL of your resource. You do a head, and what you get back is some metadata, and essentially it tells you some very trivial things. The content type, if you want to understand. You have a resource, but you don't know what it is. May happen. You just do a head on the URL, and the URL, the web server tells you what it is. In this case, it's an XML. It could also be a JPEG or something else. If you don't know it, now you know it. Last modified, this tells you the age of the resource when it has been last modified. And e-tag, this is some kind of hash code computed over the size. It is quite related. The two here, this tells you when it has been modified, and this, if you have the old one and you get the new one, then it means it has been updated. So this just may tell you that it has been updated, and the other one when it has been updated. What is here? Useful for caching. Of course, this we will see with the conditional get in a few slides. The option semantics is what I showed you before on my own website. Option is telling you which operations you can do on this specific URL. So you do options users. In my case, I did options on floriandaniel.it, and I got a 200 OK, and then allowed get head post. So again, if you don't know what you can do, you only have the URL, you don't know what you can do with it. After the head, we know that it's an XML. Now we ask, okay, what can I do? And the server tells you. If you ask, you ask with the options operation. And these two things allow us, given a URL, to understand what it is and to understand what we can do with it. Then we saw that they contain information like the last modified or the e-tag. We can use this to reduce bandwidth, for example. How? We do a so-called conditional get. So a get is always give me what is located at this resource. But it's inefficient. If you know that the resource has not been modified and you already have it in the cache of your browser or in the cache of your own application, when it's useless to fetch it again. It's just an overhead. So it has to do with performance. So there are two, it's essentially one way, but the two implementations. One is using the timestamp of the last modification, and one is using this e-tag. So you can use this last modified or the e-tag and use if modified since and if none match instructions inside your request to check whether it's actually needed to fetch the body. So what happens if the condition is not satisfied? The get will just give you a header back saying no need for an update. Let's see this in practice. With my own website, it's the easiest thing. So we do a head action here, and I get back that it has been modified last on October 11. Today? Not sure I did something. Anyway, copy. 947. What?
Last modified.
Oh, right. Sorry. Okay, this is more reasonable, but it's of course not good. 1 month ago I did the last modification. Okay, I know that last time I modified my website at this time. So I can add headers here, header instructions, and I can now put if modified since. I place the date here, and if I do this now, I get in the body nothing. So the body of what I get from my website is empty. Why? Because in the header I tell, give me the body only if it has been modified, the resource has been modified since this date. So let me change this by 1 second. We go down to 41. I send it again. And sorry, Where is it? If modified since. What am I doing wrong? I don't know. Should be working. Nobody here. Let me drop this. Of course. No. I did only head requests. Of course, when head it comes without the body. Back again. If modified since, let's put the right value here. Now we have the get. So I issue the get and I don't get anything. Now let me try again. So I suppose this works, but it can be embarrassing if it's not working. Now we get the result. So you see, if you already have it on your machine, it's useless you do it. If not, you get it. So who cares? It depends. On my website here, the HTML code here, it's relatively trivial. But look here, we have here the time. This is the time it takes to fetch the full message from the web server. So if I do this with the full body, then it's 121 milliseconds. It's about 100 milliseconds with the body. If I add the condition here and I do it again, then in average 48, 45, when it's half of the time. My website, the start page of the website is relatively trivial. If you think about bigger documents or a lot of data, there is quite a difference. I tried this thing here, for example, the HTML definition by the W3C. If I send this, it's 500 milliseconds. A few times it took even 2 seconds and so on. So it's really performance of your application. If you fetch always useless data, it's just going to be slow, your application. Okay, back to this. This is the conditional get. So I did it with the, what was it, the last modified, with the time. You could do this also with the e tag. Then, what else do we have? Headers provide metadata to assist. This is what we said. Fine. There are some header instructions next to this last modified. Last time we saw the first here in the list, which is the authorization. Remember we did the Twitter test, and there I had to get the authorization token from the Twitter server, and then in the HTTP header I had to add this authorization instruction with the right code. Otherwise it wouldn't get me any data back. This is one. Then the e tag if none match. This is basically the same as the if modified since. We just played with this a little bit. What else do they propose? The content type is what I explained, that you look at the URL, you don't know what it is, you do a head and you get the content type back and you know what you can expect. And the location is, for example, what the header carries after a post request. You send the resource there, the server creates it and sends you the URL back in the header by telling you new location, header. But there are also other, this was the post example, is the 201 created, but there are also moved permanently and so on messages. Okay, these are different headers of the HTTP protocol. There are many of them, I don't know them all. Typically you don't need them all, and as I say, many of these things are not even properly supported by all the web servers that are running there. They could be configured to support things, like with my website, I have to use FTP to upload files. Could just be a post, could be a put. It's just not a put because they don't set it up like this, full stop. If you run your own web server, then of course you can set up everything as you like, provided you are able to. So that's about the headers. So let's come back to the links. So the links are, as we said, the hypermedia. There's flying. Hypermedia, they are interlinked resources. And they express the contract. So they express how you, a contract meaning between you and the service offering the resources. It tells you, the links tell you how you can interact with these resources. And this is the same as for websites with hyperlinks you can click in the browser. The same you can imagine for RESTful web services. There are resources coming back. Some of these resources, let's say ideally all resources, all representations of the resources contain links that you can navigate. Depending on the media type of the representation you get back, either there are media types that have the concept of link in their specification. XHTML has links explicitly there. If you use your own media type, XML, you can of course put links there. It's just that a machine does not know this, cannot interpret this link as a link because there's no standard for your proprietary format telling anybody that this is a link. How do you do it? You write a documentation of your web service and you tell, look, this element here is a link. And then a programmer, of course, we are humans, we read the documentation, we understand, this link to element in your own XML format means a link that can be navigated, so you can implement your own client that is able to do this. But in order to do that, you need to, as programmer, you need to read the documentation. With XHTML, the documentation is essentially the specification of XHTML by the W3C. So it's a worldwide standard and everybody complies with it. That's one thing. Then, let's go. We said to these links, these are crucial because they actually represent then your state of interaction. The state, how do you represent it? With a state machine. It's very trivial. It's just a state machine captures what you do. These are the states, and the arrows essentially are the links you follow. So you start from one, this is a URL, then you follow one of the links in the representation you get, and you may progress through your state chart. So the arrows are the links, the resource, so the states are the boxes in the state chart.